In this video, I want to revisit an important topic I covered several years ago relating to the performance of AMD CPUs compared to Intel CPUs when using 3DCoat. The CPU multi-threading in 3DCoat utilizes an Intel compiler called Thread Building Blocks, or TBB. In the past, Intel used some rather dirty and unethical tricks with its compilers that made AMD CPUs underperform when applications used an Intel compiler. In that comparison video, it was easy to demonstrate the performance disparity between comparable AMD and Intel CPUs. Subsequent to that, I had experience with a first-generation AMD Threadripper CPU, which was a 1950X model with 16 cores and 32 threads. And though the performance seemed good overall, I could notice a tiny bit of lag when sculpting on a high-poly model that 3DCoat normally would handle with ease. However, a few years ago, I was able to test 3DCoat performance on a new high-end AMD laptop with an 8-core, 16-thread AMD CPU, which was an Ryzen 7 4800H. And to my surprise, it performed very well, noticeably better than the first-generation Threadripper. So this led me to believe that something had indeed changed with regard to the artificial hamstringing of AMD CPUs by Intel compilers. AMD filed a lawsuit against Intel back in 2005, and this practice was one of its legal complaints. In 2009, AMD won the lawsuit with a $1.5 billion settlement from Intel. To locate the part about artificial hamstringing, scroll down the document until you see the bold underlined text titled Technical Practices. Beneath that, you will see the court's ruling against Intel with respect to this separate complaint. The primary complaint by AMD was that Intel was trying to further build its monopoly of the industry by coercing computer builders such as Dell, Lenovo, and others to sell Intel exclusively or risk losing major discounts from Intel. In this video, I want to provide a demonstration for the sake of comparison between an Intel 10850K, which has specs that are marginally beneath the 10900K, the top Intel desktop CPU a few years ago, with 10 cores and 20 threads, and a new AMD Ryzen 9 9950X that has 16 cores and 32 threads. Yes, it's skewed a bit since the AMD CPU has more cores and is a few years newer. However, it does serve to demonstrate that this artificial performance hampering issue has seemingly been resolved. This should allow 3DCoat users to make a more informed purchasing decision when they are considering a new system upgrade. Much of this demonstration will be done in real time without commentary and will not be sped up in any way. So feel free to skip through much of it if you are hard-pressed for time. The best way to gauge the performance difference is to keep an eye on the FPS indicator in the lower left portion of the screen. The frames per second will often remain high, above 100, while you are applying pressure to your Wacom stylus. When you let up from your stylus, then you will often see a drop in frames per second, which sometimes results in a drop into the double-digit range. If it gets beneath 60 frames per second, that is an indication of some degree of lag. If it reaches 30 frames per second or lower, that indicates a very noticeable lag. Thus far, you can see that this Intel CPU performs very well, even when working on a 12 million poly model that is extremely dense in the head region. Skipping forward a bit, I'm going to experiment a little bit with high-frequency detail. I just switched to a skin pore brush alpha, and I had to make sure and check use current alpha in the tool options panel. Otherwise, it would attempt to use a default rounded brush alpha. I just switched in the E panel from a stamp draw mode to a brush draw mode, and I'm checking use jitter so that it applies this pattern with random variation. Next, in the toolbar, I'm going to check invert tool so that it indents rather than extrudes from the surface. As I am brushing, you can peek in the lower left-hand corner at the frames per second and see that it consistently stays above 100, indicating that the CPU is performing quite well. I think that's enough for now, so I'm going to scrub the depth opacity slider in order to reduce the overall depth. The interactivity is fairly real time, but you can see with the frames per second that at one point it dipped down into the 30 frames per second range. Skipping forward once again, I am now in the pose tool. I've already made a selection and I can see the frames per second will sometimes drop down into the 20s and 30s.
Clear the selection and create another layer. This time, I'm going to select a paint brush. Currently, we don't have like the foreground, background swatches like we do in the paint workspace. I could switch to the paint workspace to do that, but I can just use the color palette here. Okay, so let's use different brush alpha. And I'm only going to use color and glossiness, and I'll increase the roughness a bit. Yep. So again, frames per second in the body region where it's not as dense as the face region seems okay. Drops down to about 72 when I release my brush. Here in the head region, it's much more dense than the body, so it's going to be a bit slower. With a smaller brush, I think it only drops down to about 60 or so. Okay, so that's fairly good performance for the type of CPU or for the hardware that we're working with. And now I'm going to switch to the AMD Ryzen 9 9950X CPU. I'll start off, as I did previously, with a clay brush. And one thing I noticed is that when wireframe is turned on, the frames per second is quite a bit lower than when it's turned off. So in this example, it's pretty steady around 100, but when I turn wireframe off, you'll notice that it will increase significantly. I'll bring up Windows Task Manager. Under the Performance tab, you can see the CPU name as well as all the threads so that you can monitor its activity. You can also observe the utilization amount as well as the CPU speed. I'll go ahead and resume with the clay brush and toggle wireframe off now by hitting the W key. If you look in the lower left-hand corner at the frames per second, you'll be able to observe that it's well above 200 now. On average, that is roughly a 100 frames per second increase over the Intel CPU. The point I want to re-emphasize here is that the AMD CPU, being newer and having more cores, should perform much better than the Intel CPU. As I mentioned, the frames per second when sculpting, which uses multi-threading, it actually performs twice as well, and that is what you would expect. So this helps to show that this problem of artificial performance degradation on Intel's part has seemingly stopped and is no longer an issue. What that effectively means is anyone in the 3DCoat community who may be considering an upgrade of their CPU and motherboard can feel confident now in making that purchase if they so choose, whereas before that was always in question. And this likely applies to AMD CPUs a few generations back. For one thing, the 7950X is largely the same CPU as the 9950X, with the exception of the manufacturing process, I believe, is smaller, and therefore they were able to squeeze a little bit more performance and power efficiency, I think, out of the 9950X, but it's not much of a difference. All right, let's jump forward to using the pose tool. And with this model still being about 20 million polygons, it's more of an extreme use case. Typically, you would want to step down to a lower subdivision level when making very large-scale edits like this. What I'm doing here is I'm switching from line mode to paint mode, and in the E panel, I'm choosing a freeform lasso so that I can use that to drag select with a control key held down to invert. That's going to deselect instead of select, so that the only area that's selected is the arm region. Okay, now I'll switch to a brush draw mode in the E panel. I can hold down the Shift key and reposition the gizmo where I want the pivot point to be. And I can see in the lower left-hand corner, the frames per second will drop as far down as the 20s and 30s. And that indicates to me that it's not really based on multi-threading performance. Actually, one core is doing all the heavy lifting, so it really doesn't matter whether it's a much newer CPU or a little bit older CPU. It really depends on single core performance. Again, it's better to step down to a lower resolution level and the performance will increase significantly. Let's step into the Paint workspace now, and I'll do a similar paint test as I did previously. I'll go ahead and uncheck the depth channel because I don't really need it at this point. I changed my mind on the glossiness. I want to get rid of that by hitting the delete key, and it will remove all the paint information on the layer. And then I can change the roughness. So just as with the sculpting performance, the paint performance also seems to be quantifiably better than with the Intel CPU. You can see the frames per second rarely gets down into the double digits. It usually will stay well above 100 to 200 frames per second. So that's a good indicator that the performance is quite good. And with that, we will conclude this demonstration about using AMD CPUs with 3DCoat. Thank you for watching. I hope you found it helpful, and we'll see you next time.